Good morning, everyone. And maybe good evening in Europe, and maybe I don't know where where are you in the world, but say hi to everyone. My name is CJ, and I have Pierre from OVH Cloud with me. And today we are going to share our latest collaboration on Kafka-on-Pulsar, which bring the native Kafka protocol support to Apache Pulsar. And I'll introduce myself first. My name is CJ. I'm the co-founder and CEO of StreamNative. StreamNative is a startup that offering managed Pulsar service and managed BookKeeper service on different cloud provider. We also try to building a cloud native event streaming offering for enterprise. I'm also the PMC member of Pulsar and BookKeeper, and I'm based in San Francisco. And I also one of the ex-co-founder of Streamio. And I worked for Twitter and Yahoo before on mastering and streaming data technology for many years. And I have been around with Pulsar and BookKeeper for a very long time. And yeah, that's me. And if you're in Bay Area, if you want to hang out with me or catch up with me, feel free to drop me a message or DM and ping me. Yeah. Yeah.
Yeah. So thank you, CJ, for having me. My name is Pierre Zem, and I'm working at OVH Cloud. For those who don't know OVH Cloud, we are a cloud provider. In fact, we are the biggest European one. And I'm working around distributed systems. I have experiences running things like Apache Hadoop, HBase, Kafka, Flink, Zookeeper, let's say at OVH Cloud scale. I do have some contributions to some of them. For example, I have for Flink, for HBase, and now Pulsar, of course. I'm living in France, in Brest, and I'm kind of evolved into local communities such as the Java user group. We have like even a Hadoop user group at the end of the Europe. And other initiatives like Devox for Kids and so
on. Cool. Thank you, Pierre. We actually launched a poll for like surveying like how people using Pulsar, and if you're using Kafka, what kind of version and you're using, and we want to collect some of the feedback, and so then we can know how we want to provide a better service on Kafka on Pulsar. If you have any questions, you can raise questions on the chat, just on the click the Q&A, and we will try to answer all the questions at the end of the session. Okay, let's get started. Here's the agenda today, and I'll do a quick introduction. What is Pulsar, and why we add Kafka protocol support on Pulsar, and introducing the fundamental mechanism that we are using for implementing KOP, which is the protocol handler. And we'll deep dive into a bit about the protocol difference between Kafka and Pulsar, and how we implement KOP on top of that. And at the end of this session, I will try to do a demo. We will try to show how you can use Pulsar and Kafka to build a real data pipeline by integrating these two ecosystem. And let's get started. So what is Pulsar? I think we usually use one sentence to describe that. It's a flexible Pulsar messaging backed by a durable log storage. So as the first part of the sentence said, it's a Pulsar messaging system. So it covers most of the use case that Kafka and RabbitMQ covered. And you actually can use Pulsar for the use cases that Kafka and RabbitMQ were used for. The second part of the sentence is basically saying it's backed by durable log storage, and it tells the difference between the Pulsar and other messaging system. That was originally Pulsar was born for and was open source for. But after we run the community in the Apache Foundation for about more than 1 year, a year and a half, and Pulsar is actually evolving into from a pure Pulsar messaging system into more cloud native messaging and streaming system. In order to give you a kind of brief idea about what is Pulsar, first thing it provides is a Pulsar messaging system. It provides a unified messaging model, so you can it can combine both streaming and queuing into one messaging model. You can produce one copy of data, but consume the message in a different way. It's also an infinity event stream storage. The first layer is Pulsar is backed by Apache BookKeeper, which is a durable log storage, and we extend the storage capability to offloading some of the old data into tier storage, which create an infinity event stream storage story for the whole Pulsar ecosystem. And it provides the connector via Pulsar IO, so you can ingesting data into Pulsar or dumping data from Pulsar to other external system without writing any code. It also provides the capability for processing events in real time. You can use Pulsar function to write a lightweight computation logic to process events as it arrives. You can also integrate Pulsar with Spark and Flink to do unified batch and stream processing. And we also integrate Presto, which is known as Pulsar Circle for interactive queries. So as you can see, Pulsar is not just a simple PubSub system. It's actually evolving from a PubSub system into more unified streaming and messaging and streaming system. And a few highlights I want to set before the actual talk about the need of KOP is Pulsar actually provide multi-tenancy, and it's built on top layer architecture and has schema support and geo-replication support. It has a lot of cool features, and so a lot of people actually looking into using Pulsar, and we see the increasing adoption on Pulsar, but we also see a lot of inbound requests are asking for asking Pulsar to support existing messaging protocols like Kafka is one, MQP is another one, MQTT is the third popular ask. And for people to enjoy the other features that provided by Pulsar, right now you have to write your application using Pulsar client or Pulsar protocol. It requires a fair amount of involvement on migrating your existing applications from your existing messaging platform to Pulsar. Hence, in the community, we start to address some of the issues by simplifying, reducing the gap, how people want to migrate their existing Kafka RabbitMQ applications to Pulsar. The first thing we try to do is we actually provide a Java wrapper, a Java Kafka wrapper based on the Kafka Java API. For the Kafka application who use the Kafka Java client, they can just swap the dependency and just drop in the Java wrapper. You can switch in your Kafka application to using Pulsar. But it's very limited. You can only use the basic PubSub mechanism. There's still some gap in supporting transactions. And also it only limited to the Kafka application who using Java API. For those Kafka applications use librd Kafka or any other non-Java language client, there's still a fair amount of time you have to spend on rewriting of all your Kafka API application and service. So that is the current state of Java Kafka Java wrapper, and we also provide a Java a Kafka connector that is able to connecting your existing Kafka cluster with your new Pulsar cluster. So if you want to do migrating the data from your existing Kafka cluster to Pulsar, you can use the IO connector to do that. But still, those kind of efforts is just trying to providing tools in mitigations for people to switching from Kafka to Pulsar. So the idea is we might need to think about a better approach. The better approach is try to implement a Kafka protocol on top Pulsar. And there were actually two directions that we can do that. A common approach that people will try out is implementing a proxy. We call sometimes it called a gateway to put a Kafka protocol on proxy. And that was actually a approach that OVH called before. We also explored that approach a bit, but we find it's sometimes it's a bit difficult to implement Kafka protocol on proxy. And so the other approach is, how about implement Kafka protocol directly on Pulsar broker, and that kind of leads the creation of KOP. And we will deep dive into kind of these two approach, and Pierre is going to share their story about trying out bringing in Kafka protocol as into a proxy.
Yes, thank you, CJ. So as CJ mentioned, we explored the idea of translating Kafka protocol to Pulsar protocol. Why? Because we are building a new kind of product, which is called IOStream. It is like a topic as a service product, and it's heavily built on Apache Pulsar. And when we deployed it, most of our users and customers ask us, okay, so this is like really cool. It will have some cool features, but can it speak Kafka? And that's why we started to work on the Kafka support. So as CJ mentioned, we took let's say the way that was simple at the time. We just create a proxy that will translate Kafka into Pulsar. So that we wrote that in Rust. For those who don't know Rust, it's a programming language which is trying to bring nice features like garbage collecting at compile time. So you have like these raw performances. We did write that because in former work at OVH Cloud, we were struggling to configure that G1 garbage collecting on terabytes of RAM. And I'm not kidding, on the terabytes of RAM. And we said we want to avoid garbage collection on proxy layers. And also Rust is really interesting for the async ecosystem, and it has wonderful libraries to write things at TCP level. So we did start the proof of concept. Our goal was to convert TCP frames from Kafka to Pulsar. So yes, thank you, CJ. So that means that we have our Kafka clients on the left. It is speaking the Kafka protocol, and we wanted to like translate the Kafka wireframe to Pulsar wireframe. So we did like this proxy layer that we internally called Hyperion, which was translating those two. To implement that, we need to handle all the TCP connections. For example, we need to handle heartbeats from Kafka. We need to handle the lifecycle of Pulsar connection to the brokers. So to simplify things, we design everything as a state machine. So we have one state machine for the TCP connection on the Kafka side. We have one TCP connection for the Pulsar broker. And then we have another one that is like synchronizing between those two. And everything is event-driven on the message receiving by those two TCP connections. So basically, we have these state machines that are moving forwards depending on the TCP frames received by either Kafka or Pulsar clients. So this was a really interesting proof of concept. There was like good advantages of doing that. Working at TCP layers enables performances. And thanks to Rust, we were able to, in fact, our only limitation was the network card. So it was like blazing fast. This proof of concept was interesting for us to discover both protocols, as we needed to rewrite almost everything. So yes, Rust is blazing fast. If you want to try, I think you should. It's a really interesting language. We discovered that proxy file production is easy because there is like a one-for-one mapping between TCP frames from Kafka and TCP frames for Pulsar. You just need to translate them. And there was like this one advantages for the proxy is that we could bump all versions of Kafka frames, meaning that it was easy for us to say, okay, I received an old Kafka frame, TCP frame, I can bump it on the fly. So that was like really cool. But the bad part of that proven concept is that we rewrote everything. We rewrote the parsers to handle TCP packets because we were working with bytes, only with bytes. We rewrote libraries to handle the state machines and so on. So this was like kind of heavy work. I will get to it, but there is something that are really hard to proxify, notably the group coordinator of Kafka and the offset management. And also one thing that was bothering us is that we wanted to be part of the Apache Pulsar community, and we didn't know how the community will receive proxy written in a completely different language. So it was like kind of difficult to open source and to contribute back to the community. So I will dive just a bit into the problems that we hit. In Kafka, there is something like a group coordinator. You can imagine it as an elected actor, something in your Kafka cluster, and is responsible for communicating with your consumers and assigning partitions to a consumer group. And is also managing offsets. And this was like difficult to proxify because there is no such things in the Pulsar world. And the second problem was how to simulate an offset in Pulsar, because you don't have this kind of knowledge, and it was pretty hard to virtualize or to create a fake offset out of the Pulsar protocol. That's why simulate Kafka work at proxy level is super hard because basically you are missing a lot of low-level info. that are provided by the storage layer. And we were like hitting some problems on it, and then on Twitter we just discovered this tweet. This is a tweet from last summer of StreamNative, and this is Jia, and he's working with CJ, and he was like presenting a new effort of StreamNative, which is called Kafka-on-Pulsar, and it was saying that they added the support directly in Pulsar Broker, and we were like, okay, this is exactly what we need, because if we are inside the broker, we can have more access to internal stuff, and this was the thing that was missing for us. So we contacted StreamNative and we started to work on the KOP together, and that was really fun. I cannot hear you, CJ. I think you're
Yeah.
mute. Yeah.
I'm sorry. Yeah, I think it was we were actually starting the similar efforts in trying out implementing Pulsar on top Kafka on top of proxy, but we still facing the same problem. Is if you do this in a proxy layer, you are lacking the ability to accessing the storage information and also all the powerful features that providing by Pulsar. So we kind of push it down a bit, thinking about how about implementing Pulsar protocol on top, Kafka protocol on top Pulsar. So we go back to revisit what exactly is Pulsar, and this lead we kind of thinking the whole architecture of Pulsar. So this is a diagram to basically show kind of the basic component within a Pulsar cluster. So you have a BookKeeper for coordination, you have BookKeeper for data storage, ensure data consistency and availability, and all the abstraction is actually happening within this manager ledger library. So it provides a dispute log abstraction for a topic partition. And Pulsar is actually building its pub subsystem on top manager ledger. And all the features providing by Pulsar is actually like for things like geolocation, load balancer are kind of done in the topic slash manager ledger layer. And the PubSub protocol itself it's just a very simple, very thin layer built on top this topic in manager ledger. So the protocol handler, the existing protocol handler within Pulsar, it's purely just a native connection handler. It received TCP package from a client and interpret that package and convert the package into some operations that what happening on a topic or on the managed ledger, like for produce request, it would become an append operation on the manager ledger. For consume, it becomes a read request on the manager ledger. So we think the core or the actually the powers that bring by the Pulsar is actually the storage layer. So if we can provide the storage layer to developers, we actually can accelerate the innovation that the whole ecosystem or the whole developer can bring into Pulsar architecture. So we think about we are thinking how we can provide this mechanism, and this led into the creation of protocol handler. So we believe if we can abstract the existing Pulsar protocol into a common protocol handler approach, that protocol handler will be responsible for receiving the requests and the wireframes from the TCP connection. Then we can convert those TCP wireframes into operations happening on managed ledger. So we can then support different type of messaging protocols like Kafka, MQP, and MQTT, and many more other messaging protocols. So this leads into the creation of protocol handler, and we actually bring in this protocol handler as P41. For people who don't know what it is, PEEP, it's a Pulsar improvement proposal, and that is the mechanism for Pulsar community to bring in large changes. So we can abstract the existing Pulsar protocol handler into a common interface called protocol handler, and then provide the ability for people to developing different protocols for Pulsar. And so protocol handler, it's very similar as other plugins that we are using in Pulsar. Like for example, in Pulsar, you can write functions, you can write connectors, you can write an offloader. Those plugins are actually packaged into a non-package, so you can specify those plugins during your startup time. So we do the same thing for Pulsar protocol handler. So we are using none to load protocol handler, and once a broker is configured to load the protocol handler, it actually can bring up the protocol on when the broker is started. And in order to do that, it's very easy. So you just basically configure two things in your broker configuration file. The first thing is you need to specify a directory. That directory is the location for storing all the protocol handler non-packages. Very similarly as offloader. So you can just drop in any protocol handler into this directory. And the next thing is each protocol handler would be identified by a protocol ID. And you need to specify the protocol you want to enable for this broker. And you just set this through a messaging protocol property. And once it's set it, you just restart broker. And then a broker would load the protocol handler, and you enjoy a broker that is able to speak an extra protocols besides existing Pulsar protocol. So that is the mechanism is pretty simple, and the interface is also simple. Right now, we basically give all the access to the lower storage, all the storage APIs, so you can do anything you want. But at some point, we might considering how to limiting this access in the future. But at this moment, we want to give the powers to developers. They can implement, they can use these protocol handler to implement the protocol they like. Hence, once we bring in the Kafka protocol, the protocol handler framework into Pulsar, then we are able to building the Kafka protocol handler as a plugin of broker. And Pierre, you want to go to share the whole design for KOP?
Yeah. So I will show you some details about the KOP Kafka-on-Pulsar implementation. So first thing to understand is that Kafka and Pulsar are built on the same data structure, which is a distributed log. So you have this kind of base layer, which is a distributed log, and there is like similarities and words that are relevant in both worlds. Topic lookups, for example. Can I access this topic? What is the list of the topic that I can use? The word topic also is the same. Partitions, messages, offsets. These are kind of the same languages. And same thing for produce and consume. You have this idea that you are producing messages to a topic and consuming them. And of course, as always, consuming is the hard part. There is like this consumption state to synchronize on who has read what. So what we did implement them so to list topics, if you did not enable multi-tenancy on KOP, you have this namespace that you can set on the configuration, which is called Kafka namespace. We are using Pulsar multi-tenancy and bring everything to one namespace. And if you want, of course, you can enable multi-tenancy as we will after. How did we manage message ID and offsets? As we have access to the internals of BookKeeper, we can simulate the offset using the ledger ID and the entry ID. Those are internals information that are exposed by the managed ledger. So translating messages from Kafka to Pulsar and the other side is kind of easy. You just convert the key, the value, the timestamps, and the headers to the appropriate structure. For topic lookups, we are doing a regular Pulsar admin topic lookup, which is like a regular call. So our workflow is that when we are receiving message to produce, we are converting them, understand them, and then we are just calling a method which is like publish this message. And for the consumer part, it's almost the same. We are converting the request, and then we are using something called non-durable cursor, and we are reading entries on the topic. Also, there is something that is called the underscore offset topic in Kafka world. Basically, we are flushing the offset information inside that topic. So it's like an internal topic that is important in the Kafka world. We decided to mimic that feature of Kafka, so that if you have like monitoring tools that are using this topic, you can also do that with KOP. Okay, so let's do a quick checklist on KOP for production. I will go pretty quick on the list. So Pulsar is providing many things that are really interesting, like the multi-tenancy, the security, geo-replication, tier storage, schema, and integration with big data ecosystem. So this is like what Pulsar provides. As we are using, as we are running on top of the topic itself, we can check that KOP can use the geo-replication and the tiered storage, because we are it is embedded directly in the managed ledger, and KOP is running on top of it. And then there's like these things that are required to run KOP on production. We need multi-tenancy and we need security. So let's dive a bit into those and how we did implement them in KOP. So Apache Pulsar has really a great support for multi-tenancy. I think that is one of the key features of Apache Pulsar. You can just load balance traffic really easily, isolate user, and so on. So this is like a really huge feature of Pulsar, and we want to provide it in KOP. So the question is how to inject our user information. So we decided to implement SASO plane to inject your credentials. So SASO plane is like a user password that you are injecting at the beginning of the Kafka connection. So what we did is that you put the tenant / namespace as the user and your classic Pulsar token authentication parameter as the password. So that authentication is provided, and thanks to that, multi-tenancy. One thing that is really important is that Sasso plain is, as it said, plain. So it's like not encrypted. So we added TLS over Sasso plain to ensure production mode. So just giving you a quick example of how it works. So at the bottom, you have the properties that you are giving to a Kafka client. You just say, hey, this is the Sasso plain text, and there's like this template that you need to provide that will create the username and password, and you are good to go. So it's like super easy to enable multi-tenancy if your library is supporting Sasso plain. So speaking of libraries, as KOP is written in Java, it's really easy to run integration tests with the official Kafka client, Java client. But we know that this is not enough. There are many libraries and efforts to use Kafka with other languages. You may have heard of Liberty Kafka, which is the standard library used by most of the libraries. So we wanted to know how far was the KOP compatibility. So what we did is that we wrote integration tests with popular Kafka clients in other languages. So we wrote some producer and consumer in Go, Rust, Node.js, and thanks to test container, which is like a Java core library, everything is start doing integration test using Docker. So if you want to contribute to KOP, you can just easily add your favorite clients if you want to.
Yeah, okay. Thank you for Pierre for deep diving into the implementation. I think let's have fun to show some demo. And I think every engineer loves demos and try out. So the demos we are going to test here is all the demos will be made with TLS in Sasso plain. And that is, we're going to do the demo using the production, the go to production like settings. So you can actually use that for future production deployments. And the first demo, we'll try to see the interoperability between Kafka and Pulsar producer and Kafka consumer Pulsar consumer. So you can see we actually can exchange the message between two different worlds. The next thing is in order to building like a really awesome data pipeline, sometimes you need you might already have Kafka Connect that is connecting from your external system into Pulsar, and then you want to use Pulsar function to write serverless functions to processing those events. So we would demonstrate that KOP is able to work with Kafka ecosystem and as well as Pulsar ecosystem. So all the kind of demos actually written. Actually, let me share my whole screen.
In the meantime, I can answer the question that Christophe asked. He asked like this. You will have time to prepare the demo. Is that okay for you, CJ?
Yes. I'm also. Yeah. Go ahead.
Okay, so Christophe Bornet asked, is Sasso plain mandatory or only if you use tenants? So if you are not using authentication on authorization, every KOP topic is going to the namespace that is configured inside as properties, as the KOP properties.
Okay, so I actually have the demo up running. We have more time for Q&A at the end of the session. So I just share a link into the chat. That is the link that prepared by Pierre. It contains all the kind of step-by-step instructions from downloading binary from Pulsar and downloading KOP plugin from KOP, and generating the TOS related key star, trust star, and also configuring generating the tokens and enable multi-tenancy on Pulsar. So we actually have two tokens. One is the admin, the other one is me. And here are some of the instructions for configuring Pulsar to enable KOP. That is, this is actually
to configure Apache Pulsar with
authentication
enabled and TLS enabled.
Yeah, and TLS enable is more on the KOP side. So for a quick check is so basically you just need all the existing configuration are just Pulsar configurations. All you need is actually configuring the KOP TLS and configuring the protocol handler and load the Kafka protocol handler, and this is something related to KOP. These are the typical Kafka settings, like the listeners, and some of the other settings are related to the TOS, key star, and trust star. We just use plain passwords for this demo. And once you configure this KOP, you can actually just start running as normal. So in my test is actually, let me see I'm using the right terminal. Standalone. I'm going to disable function worker and this desktop. So as you can see here, is actually it tried to search the protocol and try to load the Kafka protocol from this directory. So you can see eventually the broker is up running with Kafka protocol enable. And for this test, we want to demonstrate the whole multi-tenancy features. So we actually create a tenant with StreamNative and namespace with dev, and config myself to be able to produce and consume messages from topics within this namespace.
Yes, I will allow you to do that.
Because I was actually created that, so I would let me just run this to show that I already have this tenant created. I have the namespace. This is already, I already have some kind of test traffic running before. And as you can see here is you're actually using the authentication or authorization. Because we enabled the multi-tenancy feature. And now then, if you want to, now you can download Kafka and you can configure your Kafka client to enable the SASO plan, and in order to leverage the multi-tenancy feature. I just show an example here is TLS and client SSL. So this is an example, an example of the configuration you can create for your Kafka client. It's basically using SASO plan as the authentication, and we are mapping the username to tenant namespace, and the password is your Pulsar token. Then you config to enable TLS, and this is the trust star you kind of enable. And once you have this mechanism ready, you actually can run some tests to verify the Pulsar functionality. Let me show my slides. So the first thing we want to verify is you're able to produce using Kafka producer, and your Kafka consumer is able to receiving the messages that produced by Kafka producer. So I actually open a terminal for Windows. So these two windows I have Pulsar in place, and these two windows I have Kafka in place. I'm going to run the consumer in the bottom and run producer in the top. So let's start a Kafka consumer, and it's using the client's also properties. So it actually is using the multi-tenant features, and it tried to consume from the topic called order. So let's see. Okay, it actually I have some historical data here. So you're able to receive some of the messages, and then let's try to produce to some of the newer messages. So this is a console producer. So actually, let's say hello from San Francisco. And you can see
cool.
your Kafka consumer can receive the messages, and it's all talking to the Pulsar standalone. So you can see here, it actually going into these other. Actually, I think the name here. Oh, sorry, yeah, right. It's going to these StreamNative /dev others partition 0. And the next thing we want to verify is actually the Pulsar producer. So Kafka consumer is able to receive the messages produced by Pulsar producer. So I have the another terminal opening up for Pulsar, so you can run, let's say, hello world from Pulsar, and let's type some time 2020. So you can see it actually using it separated the messages by comma, so you actually receive multiple messages. So you can see the message produced by a Pulsar producer is able to receive by a Kafka consumer. So next thing we want to verify is the let's see. A Pulsar consumer is able to receive the messages produced by a Kafka producer. So let's start a consumer first. I think it would receive some of the historical data, and let's say hello from Kafka world 2020. So you can see both Kafka producer and Pulsar Kafka consumer and Pulsar producer is able to receiving the messages from Kafka producer. So as you can see, we actually achieve the interoperability between Pulsar producer and Kafka producer. So you're able to enjoying the world that you're able to integrating both Pulsar ecosystem and Kafka ecosystem using one infrastructure. So the next thing I want to show is since producer and consumer are just kind of a library, and I want to be more concrete about the use case. And so the first thing we want to looking into is Kafka ecosystem already have a bunch of connector. So are we able to migrate those connectors into existing into KOP? So we want to demonstrate that the whole Kafka Connect can be migrated to Pulsar. So this is a very common example that Kafka community used for demonstrating Kafka Connect is you have a Kafka file source and a Kafka file sink that is connecting through a topic. So in order to configure that, I actually have Kafka Connect running on standalone. You can configure your Kafka Connect in this way is first thing you need to configure your Kafka Connect worker to using SASO plan, and you need to make sure your source, so your sink is able to use SASO plan as well, and the consumer is also the actual source is able to use SASO plan as well, because the cluster is enabled with multi-tenancy. So once we have that, we can configure, we can use the default settings that package with the Kafka distribution is we are actually reading from a file called test.txt and write to a topic called a connect test. I can actually just change that to connect test 2, so to make sure I'm not cheating. For this I would run connect test 2. So this is receiving events from connect test 2 and write to a file called test sync. And I'm just showing that there's only one connect test partition here. So there's no connect test 2. And I want to make sure the test connect is able to run. So I write some random like sentence in the file, and then I run the Kafka Connect. So it actually happened. So if you can check the testing, you should able to receive all the messages that coming from the testing. So that is the connector part. And if you want to check out the topic, you should able to see connect test to topic is created under like Pulsar. And this is the Kafka Connect pipeline. So basically the whole Kafka data pipeline is able to run on KOP. So the last thing is now you have Kafka Connect. You already have a Kafka Connect pipeline running. You want to use a Pulsar function, which is the lightweight computation framework that bring into Pulsar. So you want to process the events that produce to this connect test topic. And this would create the real kind of a data pipeline. You use Kafka Connect, you dump the data to Pulsar, and you write Pulsar function to process the event. And this would actually unlock a lot of use cases that you can combine both the Kafka ecosystem together with Pulsar ecosystem. And the next thing is I actually write I actually use the example from Pulsar functions. It basically take the string and then add and do a transformation and produce to another topic. And I config that to use, actually, let me config this using different topic. Let's say I want to produce to 3, and let's see. I'll just create a new new topic. Yeah. So as you can see here, is actually it tried to run a function, and let's see. Actually, to 3. Then I can run this connector, and you should be able to see this is kind of running, and you're able to see like we have both these KOP function output and the connect test is running. So actually I need to, I'm sorry. I need to run this consumer to consume from this topic so that you're able to see that messages that's actually producing to this topic. Let me see if I have the command running.
Okay, to recap, so we have like this Kafka Connect that is producing into a topic which is read by a Pulsar function, and this Pulsar function is throwing a result into another topic.
Yeah. So actually, I think because it actually starts from the latest position, so I need to.
Yeah, you need to re-put it, I think.
I need to re-put some of the. And I believe I need to rerun this.
So this is kind of really cool because we are fully integrated with both universe, the Kafka universe and the Pulsar universe too.
Yeah,
and
so
yeah, we've got the messages.
Yep. So this is kind of the message that because right now there's so because the function itself is actually kind of receiving these messages into a JSON format. So when you do the transformation, it's actually adding this function into as the whole JSON payload. But if you write a function, you should be able to kind of convert that in the right way. I just use an example function to demonstrate in the functionality. And yeah, that's kind of the whole demo for this Pulsar KOP. And to wrap up this is, I think as Pierre said, is we are able to kind of bring these two ecosystems together. And Pierre, do you want to share some of the roadmap?
Yeah. So KOP is open source. We will share with you the URL just after. So what are our future works for KOP? So first item would be like a KOP proxy. So the idea is to provide something like the Pulsar proxy, which is super handy to provide. That will be super handy to provide KOP into Kubernetes environments. We are not using the schema yet, so it's like easy contributions. We are waiting for the Pulsar transactions to implement Kafka transactions. And we are thinking about which protocol should we support. So we are currently supporting 2.0. Latest is 2.4, and many users are in Kafka-on. So we are wondering which one should go first, and I think the poll will help us to decide. and you too, if you want to contribute. So you can try it now. It's available on github.com/streamnative/KOP. And I think that's CJ wants to make some announcements.
So I think the protocol handler, the mechanism is in place, and we encourage people to check out KLP and use KLP as a mechanism to learn how to use a protocol handler as well. And at the same time, we also we are also building MQP and MQTT on Pulsar using the protocol handler approach. And the MQP, we are going to release the first version of MQP on Pulsar in the first week of May. And so if you're interested in MQP on Pulsar, feel free to ping us as well. And we love collaborations just as what we did with OVH Cloud. And we, as a PMC member of Pulsar, the PMC did a survey about the current state, the current adoption, and also the current community of Pulsar. And we write a survey report to show the current state of the Pulsar community and how people use Pulsar in production and what is the growth. And if you're interested in this survey report, check out the link and you can download the report and read it. And I'm going to share the slides at the end of this meeting, and so you can use the slides to find the link. Besides that, we are also running weekly live streams to talk about Pulsar and its ecosystem, and it's 1 p.m. Pacific time every Friday. And if you're interested, subscribe to our YouTube channel and set a reminder so you get notified about the upcoming live streams. We are also doing on-demand Pulsar webinar as well. So subscribe to us and watch what's new in the Pulsar community. And I think it's a time for Q&A. I'm not sure if there's any new questions coming up.
There is 2 questions. I can read it for you if you want, CJ. So Anonymous,
Yeah,
is there Pulsar Kubernetes operator?
Yeah, so I think there's actually multiple efforts on developing Pulsar community operators. One is already open source that is basically mirroring the Helm chart into operator, and it basically only do the installation, but there's no automation, auto scaling built into that operator. Internally in StreamNative, we are building a fully automated Kubernetes operators that would streamline all the operations, and we're going to share these with community soon.
Awesome.
And the next question is, can KLP be run in Kubernetes with operators? So I think the first thing it's actually Kafka protocol. There are 2 things here. It's a Kafka protocol compatible layer, so you can use existing Kafka mechanisms, like you can use Envoy, and I believe there's other kind of mechanisms for running kind of an operator-like things for exposing KLP outside of Kubernetes world. But the actual, as Pierre already mentioned, we want to bring in the Kafka's protocol support in the Pulsar proxy as well, so which is the KLP proxy. And so with that being built, you can use existing Pulsar deploy mechanism for deploying KLP. because there's nothing different from deploying a Pulsar broker on Kubernetes. So you can use the Helm chart. You can use the existing open source Kubernetes operators, or you can maybe wait for a while. We are going to release our own operator soon. So that is the second question. And what else? I see someone raise their hand, but I'm not sure where to check. Okay, if there's no,
I didn't see other questions. Just Bogdan Bunici who said, "Thanks, guys, nice work."
okay.
Oh, what about schema registry?
Oh, I see. What about schema registry? Okay, let me answer it live. So the schema is let's see. There are two things. Is we want to making sure the existing Pulsar. So we're thinking how to integrating the schema registry. So making sure you can enjoy the schemas that you already have in Pulsar, and then the other things is how we want to integrating the schema with with conference schema registry, because that is popular in the Kafka ecosystem. In terms of the schema integration, we want to do both to make sure we are able to bridge both Pulsar schema and existing Kafka schema. And that is ongoing. If you have any requirements, feel free to create the issues in KLP repo. And Pierre, me, and Ja will try to follow up on those issues, and we'll try to get that feature delivered for you for your need. Yeah. Okay, schema registry. I think is there integration with schema registry? So currently, no, but I guess the question is more about integration with conference schema registry, and that is in a plan. And we want to making sure the schema between Pulsar schema and also conference schema registry can be exchangeable. So we are able to support both, just like what we support both Pulsar protocol and Kafka protocol. Benchmarks for KLP for throughput and latency versus vanilla Kafka and vanilla Kafka. We don't publish any benchmark yet, but that is also a next item for us. But from the implementation perspective, it doesn't adding any overhead from the whole network stack, because it basically talks to the Pulsar storage directly. So we would imagine that the performance and latency should be similar as what we can provide in Pulsar. So whatever you can get from your Pulsar cluster, you should be able to get from KLP as well.
We didn't run some benchmark at OVH Cloud. We have a region running with KOP, and through the metrics, we didn't see any difference between producing into Pulsar than producing into Kafka. And so we think that we should approach the performances of Pulsar itself. And on our side, we benchmarked Apache Pulsar running what I think there was 1.8 million messages per second per partitions.
That's cool.
So that was kind of cool.
Yeah. Okay. So the last question is Apache Pim IO connector coming? Yes, there's ongoing development from Beam community. It's actually Beam community is kind of adding a Pulsar support to the official Beam repository. So there's a GitHub issue in Pulsar, and as well as Jira in Beam for tracking this progress. You can search that issue. If you cannot find it, feel free to ping me on through DM or on find me on Slack. I can point you the GitHub issue. Okay, cool. That is that are all the questions. So if you have any questions, feel free to you can follow us on Twitter. So I'm listing out all the Twitter handles, so you can follow us for any news on KLP, on Pulsar, or on the upcoming features enhancement on Pulsar. And if you really want to try out and discuss KLP, there's a dedicated channel called KLP in the Pulsar Slack. You can find the instruction to in the Pulsar website to join Pulsar Slack. That would be all today. And thank you, everyone. And at the end, we will publish the video, so you can check out the video again. And we will also publish the slide to slide share. We also send up follow-up emails to all the attendees. And thank you, everyone. And Pierre, do you want to say something?
Thank you, CJ, for the collaboration, and thank you all for listening.
Yeah, it's a great community collaboration, and we love collaboration. So if you have any collaboration requirements, feel free to reach out to me or Pierre. And thank you, everyone. Enjoy the rest of time of your day.
Bye-bye.
Bye-bye.